All right, so let's talk about something called a reaction mechanism. So when we look at an overall chemical reaction, we're really looking at the beginning and the ending of that chemical reaction when we look at the reactants and the products. We're not looking at all of the molecular steps that are happening from those bonds being broken to the new bonds being formed. So there's a lot of steps that we are not seeing when we look at a chemical reaction. Each step in a reaction mechanism is called an elementary reaction. So an elementary reaction represents a single molecular event. And again, a lot of these are being ignored. We're just looking at the beginning and the ending. So we're not seeing each of these individual steps, these individual elementary reactions. So the set of elementary reactions, when they're added together in the balanced chemical equation, give you the reaction mechanism. So the reaction mechanism is the sum of all the elementary reactions. Okay, so the overall rate of a chemical reaction is determined by what's called the rate determining step, RDS. So the overall rate of a chemical reaction is determined by the rate determining step. The rate determining step is always going to be the slowest step. So a chemical reaction cannot proceed any faster than its slower step. So if you have a chemical reaction that has 4 elementary reactions in it, whichever one of those 4 is the slowest is going to control the rate of everything else because it can't proceed any faster than that. So let's look at an example. So the rate law is only determined by the slow step, the rate determining step. So let's take a look at an example. So here we have an example of the overall reaction where we have 2 moles of nitrogen dioxide plus fluorine produces 2 moles of nitrosyl fluoride. And it has 2 steps, 2 elementary steps. The first step, nitrogen dioxide plus fluorine, gives me nitrosyl fluoride plus 1 fluorine. Well, we know this doesn't exist by itself. This is the first step. The second step is that 1 fluorine plus nitrogen dioxide produces a second nitrosyl fluorine. So we would add these 2 together to get this. You'll notice these F's are not in there because anything that's found exactly the same on opposite sides of the arrow, this is called an intermediate and it is canceled. Anything that's found exactly the same on both sides. Anyways, that's not really the point of this right now. When you're given something like this with the elementary steps, you have to be told which is the faster step and which is the slow step. So in this example, you would be told that step 1 is the slow step. So that means if you are asked to write the rate law for this, it would only come from the slow step. So if you were writing the rate law, it would just be from these two reactants. So it would be rate equals K times nitrogen dioxide to the X order times fluorine to the Y order, because the rate law is only dependent on the slow step. Because that's what determines the rate. So let's look at an example where we have both intermediates and catalysts. There's no examples of a catalyst here. There's only examples of intermediates. So there's two parts of this reaction mechanism. One is we only care about the rate determining step when we are writing the rate if you're given multiple elementary steps. The other is identifying intermediates and catalysts. So let's do an example with that. So here's a chemical reaction, and I want you to write the rate law, and I want you to tell me if there is an intermediate or a hang on just a second. Yeah, so we're going to write the rate law, see if there's an intermediate or a catalyst. So here's the example. So we have chlorine gas plus O3 gas. This is ozone. This is how chlorofluorocarbons decompose, and this is what decomposes the ozone. So we have chlorine gas, and ozone produces ClO gas plus oxygen gas. So this is step 1, this is step 2. Gas. Okay, now you're told in the problem that this is the slow step. Step 1. It's not always step 1. It was step 1 in these two examples. You'll always be told which it is. So, intermediates are something that are produced in step 1 and consumed in step 2. Catalysts are consumed in step 1 and produced in step 2. So let's see what the overall chemical reaction is, what the rate law is, and if there are any intermediates or catalysts. So I'm going to do intermediates in this purple color. So is there something that is produced in step 1 that is then consumed in step 2? So this ClO is produced in step 1. It's consumed in step 2. And it also doesn't show up in the overall equation. So the intermediate here is this ClO gas. The catalyst is something that is consumed in step 1 and produced in step 2. So here we have this chlorine consumed in step 1, produced in step 2. That would be my catalyst. And if I was to write what is the overall rate law, it comes from only the slow step, because that is the rate determining step. So the overall rate law would be rate equals rate constant times the concentration of this chlorine raised to some exponent times the concentration of ozone raised to some exponent. And we couldn't determine what these overall orders were without experimental data. So this would be a sufficient answer. This would be the correct answer based on the information that we have. So these are reaction mechanisms. We have individual steps that show single molecular events. What you want to be on the lookout for are intermediates that are produced in step 1, consumed in step 2, catalysts that are consumed in step 1 and produced in step 2. Neither of them will be in the reaction. If we were to write the overall reaction, it would be the sum of these two steps. It would be O3 gas, ozone, plus O gas produces 2 moles of oxygen gas. This would be the overall reaction. So these are some things that you might be asked when asked about reaction mechanism. You might be asked what's the rate determining step. You would be told that slow step, that is the rate determining step. You might be asked to identify intermediates or catalysts. You might be asked to write overall reactions, or you might be asked to write the rate law of the overall reaction.